Chapter 1, Section 9. Complete your warm-up. Our objective, learn to solve an equation for the value of the variable. Our essential question, how do I show my steps when solving an equation? You'll notice these are the same objective and essential question as Section 1.8. Pause as you write these down. You can solve a multiplication equation using the division property of equality. If you remember, we talked about addition and subtraction properties and keeping the two sides of the equal sign balanced. It's the same concept with the division property. You can divide both sides of an equation by the same non-zero number and the statement will still be true. Think about why we say non-zero. Remember, if you try to divide by 0, you're trying to figure out what number times 0 equals another value, and that's impossible because 0 times anything equals 0. So it's not possible to divide by 0. That's why we exclude it. But if you look at the number examples, we have 4 times 3 equals 12. If we just chose a number, we could divide both sides by that number and it would keep it balanced. So we could divide both sides by 2 and it would still be an equation. So let's take that concept further. Solve 6x equals 48. So what we're trying to do is to get the variable by itself. Now if we look at this, we're figuring out what 6 times what number equals 48. Well, I know you know the answer is 8. But what if we don't know? We need to understand how the steps work. So if we don't know what the answer is, we want to get x by itself, we have to reverse the operation. So since it's 6 times x, the opposite would be to divide by 6. Now look at how we show this. With a fraction sign. We don't use the division sign because it could be confused with a plus sign. We don't need a slash. We keep it horizontally aligned, vertically aligned, both, so that we can see it very neatly. So if you divide 6 by 6, we get 1x. So now our goal when we're dividing or when we're multiplying is to get the x to be 1x. We're not trying to eliminate it altogether, but get it to be 1x. So 6 divided by 6 is 1, and we have x there. 48 divided by 6 is 8. Now writing 1x is the same as just plain x. So you can get rid of that 1 and just write your answer as x equals 8. Now you should always check. Plug the 8 back in where the 6 times 8 is and get 48. We have a property for when we're working with division. You can solve a division equation using the multiplication property of equality. You can multiply both sides of an equation by the same number and the statement will still be true. So in our number example, we have 2 times 3 equals 6. Let's say we multiply both sides by 4. Yes, the numbers have changed, but it's still equal on both sides. Let's solve an equation that starts with division. Okay, so remember the fraction bar means divide. So what we're looking at is the variable b divided by -4 equals 5. So we're trying to think what number divided by -4 equals 5. Well, we know it has to be a negative so that we get a positive answer. And oh, yeah, I remember it would be 20, so -20. So let's show how we can solve this. Because we're dealing with dividing, the opposite of dividing is multiplying. So we multiply both sides by the number right here that's in. So what happens to those -4s is they cancel out. Because this is like saying -4 over 1 times b divided by -4. So you're really ending up with -4 divided by -4, which is 1. Then on the right side we just do the multiplication and we end up with -20. So to check our answer, we would substitute -20 in, take -20 divided by -4 equals 5. As we go through any of these lessons, if you ever come up with questions that you have, feel free to write them on the left side of your Cornell notes and ask them during class. Let's fill in the notes a little bit with some examples. First example, solve -6 times n equals 36. Okay, well, you heard me say times, So in order to get n by itself, we have to do the opposite of that, which would be divide. So we'll use the fraction line underneath both numbers, and then we're dividing by negative 6. Okay, so negative 6 divided by negative 6 is 1n. 36 divided by negative 6 would be negative 6. And remember, 1n is the same as just n. Let's check. Plug negative 6 in, so now we're multiplying negative 6 times negative 6. Well, a negative times a negative is a positive, and 6 times 6 is 36. Next example, this is example 2. In your notes, it looks slightly different. I'd like you to rewrite it so that it matches what's on the slide here, so that it's 8 equals m over 9. So let's go through the proper steps. So we see right here that it's division, m divided by 9. So in order to get m by itself, to cancel that dividing by 9, I need to multiply by 9 on both sides. And it doesn't matter what side the variable's on. We can work with it either way. So now on the left side, I have 72. On the right side, my 9's become 1m. So that's 72 equals m. Let's check. So if we take 8 equals 72 divided by 9, 72 divided by 9 is 8. Yahoo! We did it. Alright, it's time to ramp it up a notch. This is why we've been practicing showing our work, because now we're going to be able to move on and have multiple steps. Sometimes you're going to have multiple operations going on. So you may have to use 2 or more inverse operations. For example, the equation 6x minus 2 equals 10 has multiplication and subtraction in it, so at some point you have to add and divide to do the inverse. Just a few different pieces. Remember, the x is the variable. The 6 would be called the coefficient. If we were to solve this equation, we would try to isolate x. So let's try one. Solve 3x plus 2 equals 14. Your number one job is always to identify the variable so that you know what side you're working with. So we need to get rid of the 3 and the plus 2. So we have multiplication and subtraction. So at some point, to do the inverse, we will be dividing and we'll be subtracting. How do you know which to do first? Well, think about working backwards. If we're working backwards, we are really reversing PEMDAS. So we are reversing and doing adding and subtracting first, then multiplying and dividing. So we start with the number that's furthest away from the variable. And what I mean by that is consider the 3x as close together. So we would start by eliminating the 2. So to make 2 equal 0, we subtract 2 from both sides. When we've done that, we're left with 3x equals 12. We don't need the plus 0. So now we have 3x equals 12. Well, that's multiplication. So to get rid of the 3, we divide using the fraction bar, both sides by 3, so x equals 4. It's even more important now to check your answers. So if we take 4 and substitute it in, we get 3 times 4 plus 2, and we're trying to see if it equals 14. Okay, order of operations, now that we're solving, now that we're just simplifying, we need to follow them correctly. So we do multiplication and get 12. 12 plus 2 is 14. That matches our answer. Let's do the one in your notes. Solve 4y plus 5 equals 29. Step 1. Identify the variable, which is y, and then look at what's going on. Again, we have multiplication and addition, so we're going to divide and subtract, but we're going to do those in a backwards order. Subtract first. So we'll subtract the 5 from both sides. 4y equals 24. Now, second step, divide by 4 so that y equals 6. Lastly, check your answer. 4 times 6 plus 5 needs to equal 29. 4 times 6 is 24. 24 plus 5 is 29. We have a match. We are perfect so far. Some of the examples you're going to see less common or less often look like this. Now we still have to understand how this works. So again, it's the same process. Identify the variable. Now we have division, so we know we're going to be multiplying, and we have subtraction, so we know we're going to be adding. Working backwards, we add first. So we start by adding 6 to both sides. So we have x divided by negative 3 equals 21. Our next step, division. So we multiply to eliminate, cancel the negative 3's, x equals negative 63. Let's check. Negative 63 divided by negative 3 minus 6 should equal 15. Okay, negative divided by negative is a positive. 63 divided by 3 is 21. 21 minus 6 is 15. Last one. Same steps. Now we have multiplication and addition. So we do the opposite of that first. Subtract 12. X divided by negative 4 equals 1. Now we have multiplication left, or sorry, division left, so we multiply. Fours cancel. X equals negative 4. Check your answer, plug it back in. Okay, negative 4 divided by negative 4 is 1. 1 plus 12, 13, equals 13. Awesome. If any of those went too quickly, feel free to pause it on the slides, watch it again, look at the way the problems are set up, and test out your own examples. All right, your final task, make sure you've completed those notes, have them ready to go for class, and make sure you have a chance to write down your summary.